So this is honors geometry, homework section 17, no, not 17, 15.2. Volume of cylinders and cones. I already have this written out for y'all. Yeah, we are just going to walk through the problems with it written out. Hopefully that's good enough. If it's not, let me know and I won't do this again. Determine the volume of the following. This is a cylinder. The volume of a cylinder is the area of the base times the height. And the base is a circle. The diameter is 10, therefore the radius here is 5. So the area of a circle, the base, pi r squared. So it's pi times 5 squared because that's the radius. We get 25 pi. The height doesn't have to be vertical. It's 23. It's the distance between the two circles. So it's 25 pi times 23, which I believe is 575 pi cubic centimeters. Now this next one is also a cylinder. It's just oblique. It's not a right cylinder. So it's still the area of the base times the height. The height is the distance between the two circles, and that would be 9 in this case. And this is the same circle as above. I'm sorry, it's not. It's the same circle for the bases as above, but has a different height of 9. So it's 25 pi times 9, which is 225 pi. This one's interesting because they don't tell you the diameter or the radius, but they tell you the circumference. Formula for circumference is 2 pi r, or 2 times diameter. I'm going to use r because we're going to use that for our formula. Do we know the circumference? We sure do at 6 pi. We don't know the radius. If we divide both sides by 2 pi, we're going to get 3 equals r. So if we know the radius is r, if we know the radius is 3, then the area of the base, which is a circle, is pi r squared. So that's 9 times pi. That's the area of the base. Multiply that by the height of 3, we get 9 pi times 3, which is 27 pi. Number 4, this is like a part of a cylinder here. So it's still area of the base times the height. So this base is part of a circle. So how do you find the area of a part of a circle? Well, you take the entire circle, pi r squared, times the fractional part that you want, which is the angle that you have here. 360 all the way around. We're not using 90 degrees of it. That means there's 270 left. So 270 over 360 is 3/4. The radius is 2. 2 squared is 4. 4's cancel. We get 3 pi. That is the area of this base. If you then multiply it by the height of 5, you get the volume of this little fella is 3 pi times 5, or 15 pi cubic centimeters. Number 5, we have this U-shape fella with this part here in the middle missing. So to find the area of the base, we got this rectangle, and there's 2 of those. They're the same dimensions, 6 by 22. And then we have this semicircle. If we were to find all this area, but if we find all that area, we found too much because this part of the semicircle is missing. So we're going to take 2 times the area of these rectangles, because there's 2 of them, plus the area of this semicircle minus the area of this tiny semicircle. Area of a rectangle is base times height. Our base and height, as mentioned, are 22 and 6. So the area of this rectangle is 264. This circle here, the distance from here to here is 6, here to here is 6, and here to here is 6. That's 18. That means the radius of this big circle is 9. That's why this is 1/2 pi times 9 squared. This little circle here, its diameter is 6, its radius is 3. That's why this is 1/2 pi times 3 squared. Why are these halves here? Because it's half of a circle. 9 squared is 81. 3 squared is 9. 81 pi over 2, 9 pi over 2. Subtract. When you subtract fractions, you subtract the tops, not the bottoms. You get 72 over 2, which reduces to 30 pi. I just realized I made a mistake on this problem. A student had sent me an email. 36 times 15 is clearly 540, and I had written that it was 960. And I apologize. Number 6. a square hole inside of this cylinder. So we got to find the area of the base, and this base is going to be a circle minus the area of the square. Area of a circle, pi r squared. The diameter is 12, so the radius is 6. So we get 36 pi for the area of the circle. This square has dimensions of 3. 3 times 3 is 9, so this is the area of the base. Multiply that by the height of a 9er by distributing, and you get this fella. Number 7, the volume of a cone. It's a third the base times the height. When I say base, once again, that's the area of the base. This base is a circle. Pi r squared is how you find the area of a circle. The radius is 3. 3 squared is 9, so we get 9 pi square centimeters. The height is 8. It's the perpendicular distance from the base to the vertex. And that is a third of 9, which is 3. 3 times 8 is 24, so it's 24 pi cubic centimeters. Number 8, also a cone. The diameter is 8, therefore the radius is 4. 4 squared is 16, so the area of the circle is 16 pi. This cone has a height of 12, so it's a third. That's a formula for the volume of a cone. Area of the base times the height of 12. A third of 12 is 4. 4 times 16 is 64. And then we got a pi in there in a cubic centimeter. Number 9er, we don't know much about this. We do, however, have this triangle. We need to find the area of the base. To do that, we need to figure out what the radius is. This is a 30, 60, 90. If the hypotenuse is 12, the short leg is half of that, which is 6, and the long leg is the short leg times the square root of 3. So the height of this is 6 squared roots of 3. The area of the base is going to be 6 squared pi, which is 36 pi. So 36 pi times 6 times 3, a third of 6 is 2. 2 times 36 is 72. Throw a pi and a square root of 3 on there, and you're done. Number 10, this cone, if you draw the height, it splits this angle in half. So instead of this being 40, it's 20 and 20. This is not a special right triangle. We know the radius is 4. So to find the area of the base, it's 4 squared times pi, which is 16 pi. To find the height, we're going to have to use trig. Specifically, we're going to use tangent. Tangent of 20 degrees is the opposite leg, 4, over the adjacent leg of h. So we have our equation here. Multiply both sides by h. Divide by tangent of 20. Put this in your calculator. The directions don't say how to round, so use your best judgment. Your test over this during remote learning is going to be multiple choice. If this is not remote learning, who knows what it's going to be. So the volume of the cone is a third, the area of the base times the height. The base we mentioned is 16 pi. The height's about 10.99. A third of 16 times 10.99 is 58.61, and then I just left the pi there. Number 11, we got a cylinder with a cone on top. So the volume of the figure is the volume of the cone plus the volume of the cylinder. A cone is a third base times the height, and a cylinder is just the base times the height. So as far as this cone is concerned, its height is 9, so we have a 9 here, and the diameter is 6, so that means the radius is 3. So the area of this base is going to be 3 squared times pi. Once again, this third's part of the formula. 3 squared is 9. 9 times 9 is 81. 81 divided by 3 is 27. So we get 27 pi for the cone up here. The cylinder, area of the base times the height. This is the same circular base that the cone had, so it's 9 pi. Well, I guess it wouldn't have been 9 pi. This one up here was, same base, 9 pi. Then you multiply it by 8, you get 72. Add those little fellas together, you get 99. 99 problems, and a cone ain't one. Number 12, we got a cone up top and a cone on the bottom. They're the same dimensions. So the volume of the figure is 2 times the volume of one of those cones, plus the volume of the cylinder that's in the middle. One of these cones, remember we're going to double it, that's why this 2 is here. One of these cones is a third of the area of the base times the height. The base has a radius of 4, so it's 4 squared. The area of the base is 16 pi times the height of 10. That's where this 10's coming in. And then 3 doesn't go into these, so I just left it as 320 pi over 3. The volume of the cylinder, what has the same base as these, so it's also 16 pi times the height of 6. We get 96 pi. I wanted to get common denominators here so I could write the answer as one fraction. So I multiplied this by 1 in the form of 3 over 3. So we get 288 pi over 3. When you add two fractions, you add the tops, not the bottoms. So there we go. That is the end of